Assalamualaikum and hi! This presentation video is about electrodialysis, a membrane separation process. In this video, we will dive into how electrodialysis works. But before that, let's meet the team first. We are from group 11 and this group consists of 9 members. These are all the members in the group along with our matrix numbers. So, let's dive into our topic. Actually, there are a lot of common types of membrane separation process, which are microfiltration, or we call as MF, ultrafiltration, UF, nanofiltration, NF, reverse osmosis, RO, dialysis, and electrodialysis. But today, we are going to focus on electrodialysis. What is exactly an electrodialysis? An electrodialysis is a membrane separation process that uses an electric field to move charged ions through selective ion exchange membranes. Electrodialysis is a combination of two processes, which are electrolysis and dialysis diffusion. Electrodialysis also utilizes the selective permeability of an ion exchange membrane and the driving force of a potential difference in a DC electric field.
This slide will explain how electrodialysis works. Electrodialysis is a desalination process that removes dissolved salt from water, but it works very differently from reverse osmosis. In reverse osmosis, pressure is applied to push water molecule through a membrane, leaving the salt behind. But in electrodialysis, we do the opposite. We move the ion, not the water. In electrodialysis system, an electric field is applied across the water. Because ions carry electrical charges, they naturally migrate. Positive ion will move to the negative electrode, and negative ion will move to the positive electrode. To control where the ions go, electrodialysis uses ion exchange membrane. Some membranes only allow positive ion to pass, while others only allow negative ions. By arranging this membrane in alternating layers, the system separates ions out of the water and collects them in different compartments. As a result, one compartment becomes cleaner because the ions are being removed from it. This means electrodialysis can efficiently extract salt without needing high pressure.
Okay, now we will be talking about the principles of ion exchange membrane. To start, we use two different types of selective barriers in electrodialysis, which is cation exchange membrane or CEM. You can think this as a specific gatekeeper that only lets cations to pass through freely, but blocks the anions from entering. On the other hand, we also have the anion exchange membrane or AEM. This does the opposite. It lets an ion to pass while strictly rejecting the cations. The key to the process is how do we arrange them in a system. We stack them in an alternating pattern, CEM, AEM, CEM, and back to AEM. Because of this, as ions move, they will get blocked from going further in each channel. This creates two separate types of compartment: the dilute channel, where ions are removed to create clean water, and the concentrate channel, where the ions gather. This is the basic mechanism that allows for continuous separation of ions. Next, let's look at how the process flows inside the stack. First, we pump the feed water into all the compartments at the same time. At this point, the water is the same in every channel. Then, we turn on the power. This creates a direct electric field across the stack. It forces the dissolved ions to start moving. Cation flows towards the negative side, and anion flows towards the positive side. Because of the membrane arrangement, in the dilute compartments, the ions can pass through the membranes and exit. However, in the concentrate compartments, those ions hit the membrane with the same charge and get blocked and also trapped. This continuous movement leads to our two final results. One stream becomes cleaner diluted water, and the other stream turns into concentrated waste.
I will explain the 5 main types of electrodialysis and how each one works. First, we have conventional electrodialysis or ED. This is the most basic type of electrodialysis. It uses cation and anion exchange membranes arranged alternately. When electricity is applied, the ions move across these membranes, allowing us to remove salts from water. This method is commonly used for desalination and wastewater treatment. Next is electrodialysis reversal, also called EDR. EDR works almost the same as ED, but there is one important difference. The polarity of the electrodes switches regularly. When the direction of the current changes, it prevents the membranes from getting dirty or clogged. Because of this feature, EDR is very useful when treating water that causes a lot of scaling or fouling. Third, we have bipolar membrane electrodialysis or BMED. This system uses special bipolar membranes that can split water molecules into hydrogen ions and hydroxide ions. This allows industry to produce acids and bases directly from simple salt solutions without adding chemicals. BMED is widely used in chemical manufacturing, food industries, and pharmaceutical process.
Another type of electrodialysis is selective electrodialysis, or also known as SED. It uses ion-selective membranes to remove specific ions from a solution. It's especially useful when we want to separate monovalent versus divalent ions. Applications include water softening, lithium extraction, and nutrient recovery. The key feature is precision. Only certain ions are allowed to pass, making SED more targeted than conventional ED. Last but not least, reverse electrodialysis, or also known as RED. It works by placing salt water and fresh water on opposite sides of alternating membranes. Because of the salinity difference, ions naturally move across CEMs, cation exchange membranes, and anion exchange membranes, AEMs, creating a potential difference. This voltage is harvested to produce renewable electricity. RED is mainly used for power generation using salinity gradient, such as river water meeting seawater.
Now I will introduce the application of electrodialysis in our daily life. There are two primary industries that apply electrodialysis to modify and refine their products. First is in the food and beverage industry, and second is the desalination of brackish water for drinking. My focus now is to explain how and why does electrodialysis apply in food and beverage industry. Electrodialysis are widely used in food and beverage industry. It is mainly used to reduce specific ions. Electrodialysis targets to extract particular charged molecules such as acid, salt, and mineral. The reason is to reduce the acidity from fruit juice, remove unwanted salt from milk, and control the mineral content in various food products. This is important to produce a high-quality product every time. The advantages of using electrodialysis in food and beverage industry is that no heating or chemicals are used in the process, which help to keep the natural flavor and taste of the food. So, how does electrodialysis exactly work in this industry? Let's take a look at the picture on the right here. This is how the setup of conventional electrodialysis. The juice is placed in a compartment between two specialized membranes, which are cation exchange membrane (CEM) and anion exchange membrane (AEM). The CEM only let positive ions through, while AEM let the negatively charged ions passes through. Some fruit juice like apple, grapes, and orange juice can be too acidic. To reduce the sourness, electrodialysis is used to remove excess acid. How to remove those acids using electrodialysis? The acid inside the fruit juice is an organic acid that exists as anion. When the voltage is applied, it creates electric field. As we know, the opposite charge is attracted to each other. So the negative charged acid anion will move towards the positive anode and pass through anion exchange membrane AEM. The acids are trapped in a concentrated compartment away from the juice. The juice now is in the dilute compartment that contains less acid ion, which means it is less sour. Next, to control the mineral and salt level in beverage, can also use bipolar membrane electrodialysis technique. In this process, beverage with too much sodium calcium chloride flow into dilute compartment. Cation with positive charge will move towards cathode, while an ion with negative charge move towards anode. As you can see in the picture on the right, the cation such as sodium is moved to the right, meanwhile the anion, which are chloride ion, move to the left. Then the ion passes through cation exchange membrane and anion exchange membrane based on their charge. This removal ensures that the final drink has a balanced mineral composition and better taste. By removing extra sodium, improve the taste of beverage and enhance other flavor.
Desalination of brackish water. This process to remove salt ion from the brackish water. How is it work? As you know, salt are made of Na plus ion and Cl minus ion. Electrodialysis step contain cation exchange membrane (CEM) and anion exchange membrane (AEM). These membranes are arranged alternately between two electrodes, which is cathode and anode. When the electric current is applied, Na plus ion will move to the cathode, while the Cl minus ion will move to the anode. This will produce diluted water and concentrated water. Diluted water or diluted water can be used as a drinking water.
Now I will talk about the advantage of electrodialysis. First, I will talk about the flexibility, as it can be used for many different purposes. It can be treat both brackish water and seawater, and it also can be used to produce salt by concentration seawater or RO brine. Second advantage is electrolysis work more efficient at the low to moderate TDS water. This makes a great option for the treat brackish water in a small community of industry. Third, I will talk about the ability to remove specific ion. Since electrolysis costs depend on how many ions are removed, selective removal can lower energy in chemical disease. For example, it can target ion like sodium or calcium depends on what is needed. This is useful when we don't need to remove everything, just a specific ion. Lastly, it's about the cost. As we know, electrolysis only use energy depends on the amount of the ion removed, not how much the water flow the system. So if we only remove a small amount of ion, the cost can be much lower compared to other method. This makes electrodialysis more economical in many cases.
Next, I will explain the disadvantages of the electrodialysis process. First, electrodialysis is not suitable for high salinity sweater because it requires too much energy. As the salt concentration increases, the system needs a higher electrical potential to move ions across the membranes. This makes the process inefficient and very costly for typical sweater desalination. Second, electrodialysis suffers from membrane fouling caused by organic, microbes, or suspended solids. Organic matter, biofilms, and solid particles can build up on the membrane surface. This fouling increases resistance, reduces ion transport efficiency, and shortens the lifespan of the membranes. As a result, the operational and maintenance costs increase. Third, the system requires pre-treatment to remove suspended particles. Without proper filtration or disinfection, the membranes can become clogged or damaged. Therefore, pre-treatment steps such as coagulation or filtration must be carried out, which adds extra cost and equipment to the overall treatment process. Lastly, electrodialysis only works for charged species, meaning it can only remove ions, cannot remove natural molecules such as many organic contaminants. This limits electrodialysis to tasks like desalination or ion removal, and sometimes additional treatment methods are needed to handle non-ionic pollutants. That's all from us. Thank you for listening.